Alright, Joshua here. This is the third part of a three-part series, and a follow-up of the little slideshow presentation just to introduce myself to the people here of Chilliwack. And today actually I'm going to be looking around, maybe head down to Rona and look at their 3/8 copper tubing, whatever they have, and I need to find a little brass fitting, some kind of pressure fitting that could be fitted onto the copper, and so that the copper can be, the brass thread can be threaded into the side of the joe pipe, just ahead of the propane, right where you have the this spinning ball of flame, and just to observe the reactions. And the next step would be to take 6-inch nipple, 3/4 inch black steel, about 6 inches long, and to tap the copper into that, and then you can still run your air in through the pipe. But I don't know if that's going to be a good idea or not. I might have to port the air around the steam pipe, but I could try inside the steam pipe where you can mix the fan air and the steam. So it basically is going to dilute your superheated steam a little bit, which might be all right. But the reason for that is the steam going through the iron pipe. You might get more of the steam in contact with the metal, and it'd be easier to take the next step and to pack that pipe, the little 1/2 inch diameter, get some steel wool and just pack it, so the steam has to go through the steel wool, so you get 100% conversion of steam into hydrogen. And one of the things that I've read about yesterday is as this conversion is happening, it causes the iron to oxidize. And in the manifold testing that they've done on cars, the steam injectors get red hot from the combustion of the hydrogen. So it may come down to the point where you may have to make an injector, bring your steam in through the center and have an injector on the end where the injector itself is being heated red hot by the level 3 flame. It's going to be nice, bright, super bright cherry orange, and where the steam would be coming through and it'd be jetting out the end. So when it's coming through, it's going to be jetted out, but the heat of the process would get rid of any oxide or any buildup of oxide in the process. It's just a thought. This is all new to me, and I would welcome any advice or suggestions from anyone who is in this field of endeavor or have a practical hands-on knowledge of this, with this kind of stuff. This is something that you can't just go next door and knock on the doors around the city and says, well, are you familiar with converting hydrogen to oxygen? Using iron as the reformation process, and but I know the Lord can put people on your path to tweak you, right? I've seen this happen many times. But anyway, we're setting up, and need to get a small pressure cooker, just like on the Babington test, and and you use a Coleman stove to heat the external steam at this point, where the steam would rise up, go through the coil, and go back into the joe pipe and watch the reactions. And if the reactions are successful, the next step would be to build the wet and dry steamer, where the drill pipe can actually be slipped into this wet and dry steamer, where wet steam is being generated at one end. You might have like a 2-liter water capacity, which should give you about 2 hours running. And in the other tests done in Nanaimo, it was easy to convert 1 pound of water every 5 minutes. And if you could cut that in half and say, well, convert a pound of steam every 10 minutes, that would give you about 10 minutes times 6, that would give you 6 pounds of water. And that would be 16, 32, what would that be? 16, 32, 64, around 80 ounces per hour running. So that's, I guess that would be over 1 quart. But you'd be able to, you'd be able to tone it down some. But if you can get it to convert 1 quart of steam per hour, and say and use that as your aim. This is what you want to aim for. So you're actually converting 1 pound of water into 1 pound of steam, and into 1 pound of hydrogen. And since hydrogen is a very highly reactive fuel, you're not going to have to use that much hydrogen to duplicate the heat of the propane. And in other words, you're going to use a fraction of the hydrogen to duplicate the same heat results output as using propane in there. And so when you get to the point where you're burning hydrogen by itself, you can actually cut back the volume. You're not going to need so much, but you may need more air. Have to mix more air with the hydrogen in order to keep the level 3 implosion flame in operation. And so if we can get to the state where steam can be used as a supplement to super enhance the propane burn, that'd be the first step. And the next step would be to get to where you can actually turn off the propane, and the system is going to continue to run. And because the superheated steam, as it passes through the pipe, it's not combustible before the pipe, but as it's going through the pipe, it becomes combustible. In other words, your conversion process, your steel pipe being the catalyst, being the reformer, is your backflash. And if it does backflash, the fire does go back inside the pipe, it's not going any further, because steam by itself will not burn unless it's reformed, right? And if the fire goes out, you got your perfect safety switch. The fire goes out, the process stops, and all you're getting is steam coming into the drill pipe, and it's condensing into water vapor. No flammable, there's no chance that it can explode. And unless there's some kind of secondary reaction, it could pre-ignite itself, since everything gets pretty hot. And but if you got your igniter, your steel tube into your igniter, where like a big glow plug where the steam goes through, where it's converted in this iron igniter, and the chances of the fire going out it's not going to happen. And the only time that the flame is going to go out is if you cut the steam. So you just basically have a blowout valve. You turn the steam off, going to the fire, and you route the steam out into the air, and that's the end of the story. The fire is going to shut off. And so things are looking pretty good, and I know the Lord